It's magnificent. The Juno probe's mission is about to end, but its finale isn't a homecoming. It's a plunge into Jupiter's atmosphere to be completely burned up. But no one expected that in its final stages, it would capture an image that could rewrite everything we know about Jupiter. It was supposed to be a routine flyby mission. When the image was transmitted back to Earth, scientists saw nothing unusual at first glance. A vast cyclone system, just like before, with a spinning storm at its core. It was only when they switched the image to the infrared and microwave bands that they were stunned. That central storm completely vanished in the infrared. No heat, no structure, not even any depth. It was as if someone had painted a fake storm on the cloud tops. It looked active, yet it had no energy source to support it. It was spinning, but it had no heartbeat. This wasn't just weird, it was anomalous. It directly shattered our physical understanding of gas giant atmospheres. In past theories, such a storm should be filled with internal convective heat sources, with vortex structures layered on top of each other. But this image was like saying, "You don't understand anything." Scientists initially suspected an instrument error, but after repeated comparisons, they confirmed it wasn't a malfunction. This was an atmospheric phenomenon never seen before. Some have speculated it's a type of super-shallow vortex, sustained by a mechanism we don't yet understand. But for now, no one knows the truth. And this is just the first mystery Juno has left us. Over the next 9 years, it would witness the most powerful volcanic eruption in the solar system, record the first-ever collision between storms, and discover bizarre patterns on the surface of Jupiter's moons never before seen by human eyes. Now Juno is about to take its final bow. Before it departs, let's follow its gaze one last time through Jupiter's sea of clouds and see how many more mysteries are waiting to be unlocked behind this planet. Traveling to Jupiter is more than just an interstellar trip. It's a 9-year space campaign across 2.8 billion kilometers. On August 5, 2011, Juno launched from Earth. But it didn't head straight for Jupiter. Instead, it first swung past Mars, then flew back towards Earth. Was this a malfunction? No. It was a carefully designed gravity assist experiment. Engineers used Earth as a slingshot, using its gravity to catapult Juno out, accelerating it to 26,000 kilometers per hour, out of the inner solar system and straight towards Jupiter. On July 5, 2016, Juno finally arrived at Jupiter. It didn't choose a conventional orbit, but entered an extreme, long elliptical orbit, crossing over Jupiter's poles every 43 days. At its closest approach, it was only 200 kilometers from Jupiter's cloud tops. This was the first time a human probe had gotten such a close-up peek at Jupiter from this angle. It's because of this orbital design that Juno could fully scan Jupiter's magnetic field, atmosphere, poles, and deep structure. In these 9 years, it not only witnessed a supervolcanic eruption on Jupiter's moon Io, but also recorded the first ever collision between storms and captured unprecedented mysterious patterns on the moon's surface. But what truly upended our understanding was a set of data sent back near the end of the mission. In the latest round of flybys, the images and gravity readings sent back by Juno left even senior scientists in collective silence. It turns out that the colored bands we see are not just a surface coating. They are atmospheric belts that run 3,000 kilometers deep. Yes, that's nearly 270 times the depth of Earth's deepest ocean trench. This shows that Jupiter's atmosphere isn't just clouds, it's a deep system with structure and energy cycles. There is no other planet like it in the entire solar system. And between these wind bands are those legendary storms. They can swallow the entire Earth, they can tear probes apart, but somehow, they have remained stable and spinning for centuries. Even more stunning, during a close flyby on November 29, 2021, Juno practically skimmed Jupiter's cloud tops and took a breathtaking photo. The image shows bright cloud domes suspended above the storms, and the shadows they cast gave the world a sense of three-dimensional depth. Those seemingly insignificant little white dots in the picture are each as large as a city. This was the first time humanity had faced Jupiter with this kind of resolution. We discovered that the intersection of storms is not chaos, but a higher order. They collide, spiral, and churn out cyclones hundreds of kilometers deep, forming a dazzling forest of vortices. And the clouds that are ejected shoot up like fountains into the upper atmosphere, spanning 30 to 40 kilometers wide, yet they are still just minor tempests. With every detail, this planet is telling us one thing: welcome to a world where Earth's rules do not apply. The real monster of scale isn't in the movies, it's hanging on Jupiter. Its name is the Great Red Spot. This is a superstorm that could swallow Mercury and Mars, with a diameter of over 16,000 kilometers. During its 7th orbital flyby, Juno skimmed over it and captured its true face. It was no longer a textbook diagram but a real, spinning monster that has existed on a planet for centuries. And it's not the only terrifying presence on Jupiter. Every orbit around the planet has revealed a deeper layer of its madness. Take its south pole, for example. It looks as if it's been arranged by some bizarrely orderly force. Viewed from an altitude of 50,000 kilometers, several giant elliptical vortices are stably arranged around the center. Each has a diameter of over 600 kilometers, like the eyes of a giant staring at the entire planet. But Juno's mission wasn't limited to this. Another of its priorities was to check on the gang of moons orbiting Jupiter. The wildest among them is Io. This is a world about the same size as our moon, but it's packed with over 400 volcanoes. Lava flows shoot up to 300 kilometers high, like magma fountains bursting through the ceiling. The backdrop is Jupiter's giant shadow, and the foreground is a horizon constantly erupting in fire. This isn't fantasy. This is the reality Juno captured. Why is Io so restless? Because it's being subjected to a cosmic scale pummeling every day. It's in a perfect gravitational resonance with Europa and Ganymede, like three pendulums precisely aligned, pulling back and forth, causing Io's orbit to be periodically squeezed and stretched. The result is a fractured crust, roiling magma and volcanic eruptions that never cease. Juno flew by at an ultra-low altitude of just 500 miles, and captured 2 volcanic plumes erupting directly from the horizon. NASA even used these images to reconstruct one of the volcanoes, Tvashtar. That wasn't a volcano, it was a planetary-scale fountain. Magma was spewed 330 kilometers high, beyond the limits of anything known on Earth. But Io's madness doesn't stop there. In 2023, Juno captured new images of Io's Nanshan mountain area. Compared to old photos from the Galileo probe 24 years ago, the entire mountain has cracked open, and lava is flowing out. It's not a geological relic, it's a fiery planet deconstructing itself. The infrared spectrometer JIRAM recorded everything. Scientists have created the first volcanic heat map of Io. Every bright spot is an actively erupting volcano. The most astonishing is a volcanic caldera named Loki Patera, 200 kilometers in diameter, larger than the crater that wiped out the dinosaurs. The entire volcanic lake is covered by a thin crust, with islands dotted throughout and lava flows churning below. And its surface is as smooth as a mirror, like a giant glass lake in hell. This is not an exaggeration, it's the scientists' own words. In the tearing between fire and ice, it presents a morbid perfection. But the most outrageous was yet to come. Juno also discovered a strange mountain called Steeple Mountain. After 2 close flybys, its true form was revealed. It looks like a Gothic cathedral carved from volcanic rock, piercing Io's chaotic landscape. It's 7.2 kilometers high. If you were to jump from the summit, in Io's weak gravity, you would fall for nearly 90 seconds. On Earth, that's a disaster. On Io, that's the scenery. Io may be the most worthy moon to study in the entire solar system, not because it's beautiful, but because it's insane. It's like a natural laboratory the universe has left for scientists, laying out all of planetary physics on the table with its own crust, gravity, and volcanoes. For the past few decades, our understanding of it was all based on simulations and speculation. It wasn't until Juno got close that everything began to feel real. This wasn't by chance, but thanks to 2 instruments that were originally intended for other tasks. One was the microwave radiometer, MWR, used to study Jupiter's atmosphere, and the other was the infrared spectrometer, JIRAM. They weren't designed for Io, but engineers forced these 2 pairs of eyes to turn towards its crust, like using a medical CT scanner to scan a planet's bones and blood vessels. The results were shocking. There is still flowing magma beneath Io's crust. About 10% of the surface has slowly cooling lava zones beneath it. In other words, Io is like a planetary-scale engine. The surface crust is constantly being renewed, while the inside is forever boiling. Volcanic magma pipes, thermal circulation, the entire moon is like a giant radiator that never turns off. It continuously releases its internal heat flow into the universe, like a space race car constantly spewing smoke in a vacuum. But that's not even the craziest part. In December 2024, Io experienced its largest recorded eruption. For 3 full months, the volcanic plume covered an area of over 65,000 square kilometers, equivalent to the entire country of Japan being submerged in lava. The energy released was a staggering 140 to 260 terawatts. To put that number in perspective, the total power output of all of humanity's power plants combined doesn't even reach 1/10 of that. This wasn't a geological event, it was a planetary energy flood. NASA scientists are now awaiting Juno's next flyby. It will once again get close to Io, at its nearest point less than 80,000 kilometers away, like listening to a planet's heartbeat to see if it will once again erupt with the fury of an entire crust. And echoing Io's volcanic heart is another shock that Juno brought from Jupiter itself. We've long known that Jupiter's magnetic field is strong, but we didn't know how outrageous it was. Juno measured that in some regions, Jupiter's magnetic field is more than 30 times stronger than Earth's. That's not a matter of a compass needle twitching, it's a matter of every instrument on a probe screaming alarms. So where does its magnetic field come from? The answer is liquid metallic hydrogen inside Jupiter. This is a bizarre substance that only forms under extremely high pressure. It's both like a liquid and a metal. It can flow and conduct electricity. It's because of the existence of this flowing metallic core inside Jupiter that it creates the strongest magnetic field system in the entire solar system. But Juno's MWR instrument found a key detail. This metallic hydrogen is not buried deep in Jupiter's core. Its starting layer is much closer to the surface than expected. This means our long-held belief that Jupiter has a solid core and a clearly layered internal structure may be completely wrong. It's not just a simple planet. It's like a giant misunderstood reactor, hiding the flaws and arrogance in our definition of a planet. Juno didn't just verify old theories, it completely tore apart a 30-year-old data mystery. In 1995, the Galileo probe descended into Jupiter's atmosphere and found the upper layer to be unusually dry, with only 1/10 of the expected moisture. At the time, scientists thought it was a coincidence, that the probe might have fallen into a dry hotspot. But now we know it wasn't by chance. It was a hidden mechanism that Juno uncovered in the same region. It found that in the equatorial zone, shallow lightning causes water and ammonia to combine into hail. These hailstones, like gas bombs, carry the water and ammonia into the deep atmosphere, making the upper layer dry and leaving behind a misleading illusion. So that mystery from 30 years ago was never a misjudgment. It was just that we didn't understand this planet well enough at the time. The most captivating part of science isn't the answers, but the moments it proves you wrong. And every close approach by Juno reminds us that Jupiter is far deeper, hotter, and more unreasonable than we ever imagined. Although Juno's mission is nearing its end, it is still uncovering Jupiter's secrets. On April 29, 2025, NASA released new data about Jupiter's south pole, those polar cyclones that sit as still as a clock. This time, the image shows 8 large atmospheric vortices circling a central one, arranged in a neat formation, like a ritual array around some mysterious core. Each of them has a diameter of over 2,000 kilometers, roughly the distance from Beijing to Guangzhou. But these behemoths are unusually docile. They don't erupt like Earth's hurricanes, tearing things apart and dissipating. Instead, they persist for a long time, spinning stably, almost as if they are chained to Jupiter's pole. Scientists use Juno's JunoCam and infrared camera JIRAM to track how they slowly move around the central storm. Under the influence of the beta drift, they slowly approach the center, but between them, they push against each other like compressed springs, neither merging nor collapsing, but forming a nearly eternal ring of vortices. This kind of structure doesn't exist on Earth, but on Jupiter it's the norm. Juno has allowed us to see for the first time that, on this gas giant, the weather is not chaos, but some kind of order we don't yet understand. In September 2025, Juno will complete its 77th and final orbit and will be guided to plunge into Jupiter's atmosphere, where it will burn up, completing its last mission. 9 years, 77 orbits, countless adventures through storms. It has brought back not just photos and data, but an ever-expanding list of questions. We thought it would give us answers, but what it has left behind is an even greater unknown.